Hello dear children, in this video we are going to learn a very important question, that is work-energy theorem. Dear children, usually this question is asked for 8 marks in a board examination. You don't believe that 99.99% this question is the most expected in a board exams. Okay, so children, before going to learn what actual work-energy theorem, let us see how the marks distribution will be. So, how to score 8 marks in 8? First, I will tell you how the marks will be distributed so that we can learn and we can score 8 on 8 marks. Okay, children, first. So, when you take 8 marks, children, first 2 marks will be for definitions. I mean what? For writing work definition formulae, energy definition formulae. It carries 2 marks. Am I clear? Fine. The next 1 mark for writing a statement of work-energy theorem. 2 marks for definitions, 1 mark for theorem. So, 3 marks is over. Next 3 marks for proving work-energy theorem. Okay children, then here you may get one doubt. Sir, you said that it is 8 marks, but till now only 6 marks are over. Whatever 2 marks, yes, I am coming to that point only. Children, whenever work-energy theorem is asked, one numerical will be attached to it. So, which means what? We have to do the work-energy theorem along with the numerical. So, that numerical carries 2 marks. 6 plus 2, 8 marks. Children, in this video, we will be discussing in detail. Even I will give you notes. If you can write these notes as it is with the numerical, I am damn sure that you are going to get 8 and 8 marks. So, children, shall we start? Yes. First, we are going to discuss work definition. Children, after learning work definition, we will discuss the energy. Children, let us say here a body of mass m is there. Okay, on this body, let us say force F is applied. So, whenever force is applied, children, usually what do we expect? We expect that body will be displaced. So, let us say that this body is displaced till here. So, that children, there will be a displacement S. There will be a displacement S. Then we can say that work is done. I mean children, how to define the work? Work is said to be done when a body is displaced in the direction of applied force. So, let us learn the definition also. Just try to copy it first. So, this is the definition. Work is said to be done when a body is displaced in the direction of applied force. Then here we can write work is equal to force into S. So, this is work formulae. This is a work formulae. Then come to the energy. Actually, you may get one doubt actually. Sir, energy means we have many types of energies. Which energy should we define? Actually, very important. Whenever a force is applied in a body, what will happen? Body starts moving, which means what? Body has velocity. So, all do we know that the energy possessed by a body by virtue of its motion is called what? Kinetic energy. So, here we have to learn the kinetic energy. So, children, let us learn the definition of kinetic energy. So, children, this is what actually kinetic energy definition. Okay. So, the energy possessed by a body or an object by virtue of its motion is called kinetic energy. For suppose children, here is body of mass m moving with velocity v. Then kinetic energy expression we can write as a K is equal to half mv square. So, dear children, look at here. So, writing definition with formulae, what happens? We are going to get 2 marks. Okay children, just you copy this. Now, we will prove work-energy theorem. Means first we will see what actual work-energy theorem and how to prove it. Just copy it. Fine children. Now, let us see what actually work-energy theorem and what does it state. It's very important. Children, work-energy theorem states that work done by all the forces is equal to the change in its kinetic energy. Okay? I hope you are not clear with the statement. Let us discuss in detail so that you will get a clarity. So, children, for that, let us take here is, let us say it is a body of mass m. Children, let us suppose initially it is moving with a velocity u. Okay, now fine. On this body, let us say force F is acting in the direction of motion. Children, it's very important. When a force acts on a body in the direction of motion, obviously its velocity increases. Then what happens? You may get wonder out, sir, why it is like that? What happens when a force acts on a body in opposite direction of its motion? Obviously, what will happen? Its velocity decreases. So now we are taking a case where the force is acting in the direction of applied force. So what will happen? Definitely body velocity going to increase. So let us say v is the final velocity after some time t. After some time t. So such a that v is greater than u. Children, here it's very important. As there is a change in velocity, obviously there will be a acceleration. Body has some acceleration and the displacement covered is s. Okay. Children, try to understand. This is actually situation. Okay. Now let us start here. Children, we know that already work is equal to F into S. Why I am taking F into S? Some of you may get wondered, sir, W is equal to Fs cos theta. But here I said that force is applied, a body is displaced in the direction of applied force. So whenever a body is displaced in the direction of applied force, you can take W is equal to Fs directly. Nothing is wrong in it. Okay, fine. Let us say it is the equation 1. But children, we already know that from the Newton's second law of motion, children. What is the mathematical form of Newton's second law of motion? That is F is equal to ma. Let it be equation 2. And children, once again let us recall equations of motion. We have 3 equations of motion in which we are going to use this equation. V square minus u square is equal to 2as. Children, from this, can I write like this? S is equal to v square minus u square by 2a. Yes, we can write. Children, carefully observe these 3 equations. So, can we substitute second equation, third equation, first equation? Of course, we can substitute. Look at here. So, here substitute equation 2 comma equation 3 in first equation. Then what are we going to get? W is equal to, in the place of F, we are going to substitute ma into, in the place of S, we are going to substitute v square minus u square by 2a. Children, a gets cancelled. Then this is going to be mv square by 2 minus mu square by 2. So children, can we write like this? W is equal to half mv square minus half mu square. Yes, obviously. Now children, just try to notice here. What is this half mv square? Kinetic energy. Half mv square kinetic energy. But thing is that half mv square is a final kinetic energy. Half mv square is a initial kinetic energy. So this we can write like this. W is equal to final kinetic energy minus initial kinetic energy. So finally we can write W is equal to change in its kinetic energy. Change in its kinetic energy. You may get one doubt. So change in its kinetic energy means whether kinetic energy is increasing or decreasing. Children, it depends on whether the force is acting in the direction of motion or opposite direction of motion. So if force is acting in the direction of motion, then what will happen? Kinetic energy increases. This will be a positive value. If not, what will happen? If a force is acting opposite direction of motion, then kinetic energy decreases. So work is equal to change in kinetic energy. But dear children, the very important. So whenever we are calculating the work, by which force you may get one doubt, children. It's very important. Here work done by all forces. All forces in the sense what? It might be external forces, it might be conservative forces, it might be non-conservative forces. So whenever we write a statement, we have to mention like this. The work done by all the forces is equal to the change in its kinetic energy. So let us write the statement. So children, this is what actually statement we have to write. So it states that work done by all forces is equal to the change in its kinetic energy. So children, by doing this derivation, by writing this statement, you are going to get more 4 marks. So 2 marks already discussed for definitions and 4 marks here. So till here, if you can write as it is like this, you are going to get 6 marks. But children, our target is what? 8 marks. To get 8 marks, we need to do the numerical. Just copy this, that numerical we are going to do it. Just copy it. Okay children, now you can see the numerical on board children. So as per the numerical children, it is given that, so a bullet gun is firing 360 bullets per minute and mass of each bullet is 5 grams and it is coming out of the gun with 600 meter per second. Then we have to calculate the power of the machine gun. So children, first let us read the data. I mean what is given, what to be calculated. Then we will get an idea. So it will become very easy to us to solve it. Okay, fine. Look at here. So it is given that mass of each bullet is 5 gram. Children, as it is given in grams, let us convert it to 1000. How? By dividing with 1000. That is 5 by 1000. This is the mass of the bullet. And time is given here is 1 minute. So 1 minute is equal to 60 seconds. And each means velocity of each bullet is 600 meter per second. Like that, how many bullets are coming? 360 bullets per minute. Then they are asking us to calculate the power. Children, what is the power here? So basic definition we all know very well. Power is a rate of doing work actually. That is what? Power is equal to work by time. But here what? At what rate the bullets are coming out of the gun? Children, of course here gun is doing work. For what? In order to send the bullets outside. But just to think that whatever the work is done today children, that is what is happening. They are sending the bullets outside, which means what? Bullets are coming out with certain velocity. Means what? They have kinetic energy, which means what? Whatever the work is done is converting into kinetic energy. So here work is nothing but actually kinetic energy. Children, for suppose let us say only one bullet is coming out. Then how to calculate the kinetic energy? For suppose children, here is only one bullet of mass m, velocity v. Then its kinetic energy will be half mv square. Children, try to understand. This is the kinetic energy of only one bullet. If n bullets are coming out, what we have to do? We have to multiply with n bullets, n number, n. We have to multiply with the total number of the bullets, then we will get the total kinetic energy. Okay. So here we can write power is equal to half mv square children. This is the kinetic energy of the one bullet. If I multiply with n, what will happen? Kinetic energy of the n bullets. Okay. By time. That's it. Now you substitute the values, then we will get the answer. So let us substitute the values children. Here n is 360 into, it is half into, mass is given 5 by 1000 into, v value is 600. So as it is a v square, we are going to write it as a 600 into 600 by, as usual, 60 is there children. Now here 3 zeros cancel, 60 is cancelled, 2 ones are 2, 180. So here what are left here children? 180 into 5 into 6. Children, if you can simplify this, you will get 5400 watts. 5400 watts. So according to scientific notation, it can be written as 5.4 kilowatt. So children, this is the power of a machine gun. Okay children. So with this, we successfully completed 8 marks question. So children, I repeat once again, definition carries 2 marks, statement 1 mark, verification 3 marks and numerical 2 marks. So with this, total 8 marks question. Hope it's a very clear, hope you all have understood. Okay, next video we are going to discuss one more 8 marks question. Okay children, thank you so much, all the very best.